All right, everybody, it is day 14 in geometry, and today is Wednesday, June 18th. So I'm going to write that on my paper. Okay, Wednesday, June 18th. So we have started kind of picking up the speed in the last few days. We just kind of flew through 2 units. We did unit 3, where we talked about quadrilaterals, polygons, area, perimeter, all those things. And yesterday we learned about circles and all sorts of other different things. We talked about regular polygons, but the theme here is that we have been looking at 2-dimensional shapes. So I'm going to write here 2-dimension shapes. 2-dimensional shapes. So, does anybody know what I mean by 2-dimensional? Erica?
A shape that does not exist within the third dimension. It has no mass.
No mass. It's only 2 dimensions. It doesn't exist within the third dimension. Does anybody know specifically what I mean by dimension in general? Like, what does that word even mean? Any ideas? Now, you're correct in what you said, but if I could simplify this word.
I think like flat.
Yeah, like flat, kind of like surface,
Yeah.
almost. Dimension is actually really just a fancy word for a measurement.
Yes.
A 2-dimensional shape is 2-dimensional because we can measure 2 different things about it. There's like a height and a width, or a length and a height, or like side. 2 dimensions are something like a square. That has 2 dimensions. So like 1 dimension here, 2 dimensions. A triangle. 1 dimension is the height of it, the other is the width of it. But it's flat. It's flat. This doesn't pop off my page. 2-dimensional shapes are flat. Now, if I wanted to go and describe 2-dimensional shapes with specific measurements, we have things like perimeter, and that measures, what does perimeter measure?
Around an object.
Yeah, it's like the length around the object. The other thing we measure in 2-dimensional shapes is area. And that's where we take the 2 dimensions and we multiply them and we see how much space does it take up. So those are the 2 different things that we can find with 2-dimensional shapes. But we're going to go into the next dimension today, because our world is not flat. We have things that aren't just smushed up to the ground. We can move around, we can stand, we can move things in more than just 2 directions. There are 3-dimensional shapes as well. So, 2 dimensions are flat. 3 dimensions are what we would describe as solid. It's like a sphere, like a cube, like a person, like anything that is not flat. So I'm going to say it is solid. It pops out. I'm going to show you how to do a quick sketch of a 3-dimensional shape. It's It's not too difficult, and it's kind of satisfying to do. So, if I wanted to draw a two-dimensional shape, the easiest way to start, or a three-dimensional, the easiest way to start is by starting with a little bit of space above. I'm going to give myself a few lines, and I'm going to start with a square sort of shape. So here is a square. This is two-dimensional. I only have a height and a width, or a length, you know. What we're going to do now is extend this shape so that it has a depth. I'm going to take from the very corner or the edge of one of my shapes, or I'm going to go like this. I'm going to make a tilted line. Now, to make sure that it really does look three-dimensional, you can take a ruler and make sure that you're going at the same angle on the next point. So you see how I've got, let me make that not such a glare. I'm going right about at this angle, so I'm going to want my next line to go about the same angle. About like that. Okay, so I've got two lines coming off. And now I want to go ahead and extend this third vertex, this third point as well. And I want to try to line it up as close to the same angle as those other lines. Like that. Okay. And now we can connect these. And we have like a cube here, which is kind of cool. If you want, you could draw the other face. You could make like a dotted line going down so that it really looks three-dimensional. See, look at that. Kind of cool. This has more than just two measurements. Now we have height, we'll call this I don't know what I want to call that. Maybe the length of it. We usually say base, but I'm going to say length. And the third dimension now goes this way, across this side of the shape. You see that? This is our width.
Now, is this the length times width times height?
Yes. Length times width times height. So, we've been talking about perimeter. We've been talking about area. But now we have a third measurement we can find, and that would be called volume. You may have heard about this in science class. Volume. And volume is going to tell us the solid area inside of a shape. It's not just how much space does this square take up. How much space does this whole 3D object take up? So we, to find volume, do the length times the width times the height. Length times width times height. And so we can also write that as V equals LWH to abbreviate. Make that a little easier to see. Now you can make any 2D shape. When I say 2D, I'm abbreviating two-dimensional. You can make any 2D shape into a 3D shape just by extending it and creating width. So I could maybe do it with a triangle as well. I could take that and go 1, 2, and connect it, see? And now I've got like a 3D triangle here, yes.
Are we gonna be covering, Mobius strips with my box?
Mobius, say that again?
Mobius strips?
Mobius strips. Is that like the net of a sphere where it's like the
It's-
strange?
It's a shape where you can do it with a strip of paper, where you take a long strip of paper and then you give it one twist. And
I know what you're talking about. I hadn't planned on that today, but that would be super interesting and we could totally explore that. I would love to look into it. It's a good idea. Okay, so we have a volume formula. Now, let me give you the units for volume. First, we have perimeter. We measure that. If we have inches, we would say perimeter is in inches. What about area? What is the units for area? Inches squared. Now, the reason for that is because perimeter is just measuring a length. So it's just one dimension. Area measures the height and the length together. So that's how we get the squared. So we've got like x squared. But what about when we add a third dimension? What do you think that exponent will become? A 3. Now we're in the cubed dimension. Now we have inches cubed. Because we're not talking about these flat square inches anymore. Now we're saying I can fit this many inch-sized cubes into this shape. That's what we're measuring. Okay, can I move this, or is anybody still copying it down? I'm happy to wait. I see a few still writing. I'll pause it for just a moment and let everybody kind of finish that. Okay, so I'll keep this here for a minute, but I'm going to pull out a few examples for you of three-dimensional shapes and how they're made up. So, I have here from the top what looks a lot like a square. But when we turn it, we can see it's a cube, right? So what's cool about this cube is I can open it up and let me see. A cube can be flattened out into a two-dimensional shape, and here's how. If I open up my cube and lay it out, now we have the net. This is called a net. Basically, it's all the two-dimensional pieces, the faces, that create a three-dimensional shape. So, today we're going to do some experimenting with these nets and making our own three-dimensional shapes. So, we're going to end up folding these up and creating shapes today. So I'll put that up. But you'll notice with different kinds of 3D shapes, for example, we have this triangle one. All we did to extend that is add these kind of square rectangular pieces to the side of two triangles. You can do that with any shape, and it becomes what we call a prism. A prism is basically just when you take a shape and you double it. So now I've got two triangles, and in between the triangles I put solid bits of like a square or a rectangle, something like that. So I can see if I were to open this one up, let's see if I can do that. Here's my triangles, And there's the 3 squares we attached. Here's the net of my triangular prism. Kind of cool. So there's that. Let me put that back in here. Okay, now let's see. Can I move this page now? Have I given you enough time? Okay, I'm gonna move it on. So, each 3-dimensional shape has what's called a net, like I just showed you. So let me just title this real quick. Okay. So each 3D shape has a net. I'm going to write that. Each 3D shape has a net. And the net is all of the faces or the flat surfaces of that 3D shape laid out, connected together. So, on a cube, for example, I would like for us to see how many faces this cube has. Now, faces, remember, is just the flat parts of the shape. So, let's see. Let me get something to mark here. Where's my dry erase marker? There we go. Okay, so here's a face. So that's 1.
6.
There are 6. So I've got 1, 2, 3, 4, don't want to count that twice, 5, 6. This is also why a die or dice has only numbers 1 to 6, because there's only 6 faces on a die. So a cube has 6 faces, just like that. And that's why whenever we make the net of a cube, it's going to be made up of 6 squares. So what I would like us to do is try to draw a net. So we're going to draw the net of a cube. And the cube will have a length of 1 inch, a width of 1 inch, and a height of 1 inch. So we can use our rulers to make sure that we're drawing it accurately. We just need 6 of these squares. So I might start with 1 inch here and 1 inch here, 1 inch here, and 1 inch here. So there's my first square, 1 inch. And what we need to happen is we need at least, we need to just keep repeating this square until we have, you'll notice like on this cube, there's 1, 2, 3, 4 in a row. 1, 2, 3, 4. And it starts over. 1, 2, 3, 4. So we're going to start with 4 of these squares right on top of each other. So there's 1. Now I'll make my second one. And it doesn't have to be perfect. So that's 2. We'll draw another one. 3. Now you could do this in probably a quicker way by just drawing a 4-inch line first and then separating it, but we're doing it slowly. And one more box, 4. Okay, so there's 4. Now, we just counted, there's not just 4, there's 6. So, we're going to need 2 more boxes somewhere on this net. I could really, like in this one, it looks like they're going between the 2 and the 4. It doesn't matter where you put the other 2, as long as they're not on the ends. I could put one here, I could do it here, I could do it here, I could do it here. It doesn't matter which place we put them in, because whenever we fold that up, here, I'll take this out again so we can see. Whenever we fold this up, these 4 boxes in a row are curling around themselves. So it wouldn't matter if my flap was on this edge, if it was on this edge, it won't make a huge difference. So I'll put one, let's see, here, and here, and there we go. So I'll call that 5. And you could put 6 right next to it, or you could put it somewhere else if you're just feeling fancy. Yeah, you do want to make sure it closes up. So I'm just going to put mine side by side so they create this sort of cross shape. And there's 6. So here's my net. And luckily for us, every single line on this net has the same length. They're all 1 inch. Not that we have to label all of them, but I'm just doing it, I guess, for fun. It's all 1 inch. So if I wanted to know, once I have this all folded up, what the area of just one of these faces would be, how would I find, for example, the area of one square?
You take 1 times 5, right?
1 times is
No. 4. We'll count all 4 sides.
You're very close. I think you might be thinking of the area of the whole thing. I'm thinking of just the area of this one little box.
1 times 1?
1 times 1. Base times height. That's all it is. This one little square is two-dimensional, so we can find an area that way. Area is base times height. So the base is 1, the height is 1. My area would be 1 inch squared, because 1 times 1 is 1. Okay, this is 1 square inch. Since all of these squares are the same, they're all the same, how could I find the total area of all the squares together? Yes, Shayna.
What if you 1 times the number of boxes?
Yes, you're just going to take 1 times the number of boxes, or the number of faces. So how many faces do I have here? 6. So what we're going to be finding here is called surface area. Surface area. All that is the area of each face, the area of each flat surface, and we add them all together. All of these areas are the same. There are 6 of them, so I'm just going to take, let's see, surface area is the combined area of all the shapes, faces. This cube, each face is 1 square inch. There's 6 of them. 6 faces. 1 square inch each. So we just take 6 times 1. Or you could do 1 plus 1 plus 1 plus 1 plus 1 plus 1. 6 times. So 1 inch squared times 6. What would my surface area be? 6 inches squared. This is 6 square inches. And then we're going to talk about how we'd find the volume of this shape. So on the previous page we said volume can be found by taking the length times the width times the height. So I'm going to write that V equals length times width times height, and that's right here. Length, width, height. So what problem, what math equation or expression am I writing to find the volume?
That'd be you said the length.
Mm-hmm.
Width and the height.
Yep. And we're multiplying them. So why don't I plug those in? What's my length? 1 inch times what's my width? 1 inch times what's my height? 1 inch. What's 1 times 1 times 1? 1. Not the best example because 1 doesn't mean a whole lot. But in terms of units, since we did 3 dimensions here, we have 1 inch to the 3rd power, 1 inch cubed. That's the difference. Volume has 3 dimensions. Area has 2. Kind of strange. Kind of strange. Okay. What if, let me move this a little bit. What if I wanted you to find the volume of what if we find the volume of a cube with a length of 5 inches, a width of 5 inches, and a height of 5 inches? How would I do that? 5 times 5 times 5. And what does that give us? 5 times 5 times 5. 125 inches cubed. Good. Inches cubed. How could I find the surface area of this cube?
You take the length times the height.
The length times the height. What would that give me? 25. So here, let me write this. Surface area of this same cube. Remember, we're just going to start by finding the area of one of the flat surfaces. So we'll take the length times the height. So 5 times 5, and you said that was 25? So 25 inches squared. And how many faces does a cube have? It has 6. So we take that area we found, 25, times 6. And what does that give us? It'll be a little bigger than 30.
Probably put it in wrong.
What was it, Lisa?
150. Yeah.
150. Good. And that's still inches squared. Number of faces.
Don't you take that number times the width?
For surface area, we don't need to do that. For volume, we're using all 3 dimensions, the length, the width, and the height. But surface area, we're just finding the area of all the flat pieces, not the chunk inside of it. Okay, so we will do a few more examples using the volume formula, and I'm going to give you a more concrete formula for surface area, because we've more so just talked about the concept of it. If surface area is feeling a little bit confusing, it's because of the way I presented it. It's not your fault. I'm going to make it easier in a second. But I'll leave this up for a minute if anyone's copying it down still. Okay. We'll pause this for a second while people are finishing up. We'll go ahead and move to our next page and we'll do some examples. And if anybody does still need to see any notes or they aren't getting it down quite in time, just come talk to me after class. I'm happy to give you a copy or let you borrow my notebook. Let me title this page. Geometry. This is now page 3. So, let's specifically give a few formulas written in a slightly less crazy looking way. Cube. For surface area, we do have a formula, and that formula might look strange at first, but we can talk about it. That formula is going to be 6, and we will call the length, width, and height. We're going to call all of those S, since they're all the same for like a side length. So S, 6 times S squared. How does that make sense? Does anybody have an idea of where this formula may have come from, Erica?
All you're really doing is looking at each side of the cube that has a two-dimensional shape, and then you just multiply that by the sides.
Perfect, perfect. That's all we're doing. A cube is just 6 squares put together. Remember, we've got 6 squares in here. And so to find the area of one square, we're taking the side length and we're squaring it. Side times side. Side, side, side. So side times side is the same thing as side squared. And then there's 6 of them, so we're taking it times 6. So that's where that formula comes from. And we also have a volume formula. And that formula is just S cubed, which means S times S times S. Now, does anybody have an idea of where the S cubed may have come from? Side times side times side. It's that length times width times height. The length is the same as the width is the same as the height. In a cube, all of those lengths are the same. So we can just multiply by itself 3 times to get S cubed. Now, just to make sure we know how to do that on a calculator, this will save us some time. If you all would get out these yellow calculators, if there's not one at your table for you, feel free to go to the computer cart and grab one. And we're going to practice a few of these. I'm going to write find surface area and volume, and I'm abbreviating. Let's say I have a cube where the side length is 28.2 inches. If I know what S is, all I need to do is plug it into each of the formulas. So for surface area, here's what we would type in to the calculator. 6 instead of S, 28.2 squared. So let me do that. 6, oops, There we go. 6 times 28.2. And for squared, we can just hit the x squared button. And we get a very large number. 4,771.44. Oh no. So I'm going to write that down. 4,771.44, and our units are inches squared. Now for volume, we need to be able to do a cubed on a calculator, so I'll show us that. Volume is just S cubed. S is 28.2, so we need to type 28.2 cubed, and here's how we do that. We're going to start on our calculators, let me find the right angle, by typing 28.2. Now to get a different exponent than 2, you are going to, under your clear button, hit the up arrow. And now you'll see you've got a flashing box. And then you're just going to type the number you want there. And in this case, we want 3. Hit enter. And there's 28.2 cubed. Yeah. 22,425.7. If we rounded, it'd be 0.77. So volume is pretty simple to find in a cube. You just type the number in, put the little 3 up there, hit enter. So our volume, let me write that in. Volume is 22,425.77 inches cubed this time. Cubed. Okay. What if I gave you a cube with a different side length? What if it had a side length of 32.5 inches? I would like for you guys to try to find the surface area and the volume. So use the surface area and the volume formulas and find each for this side length, 32.5. Try that on your own. I'm going to pause this. Okay. Titanium. What's the surface area?
32.5. So you take 6 times 32.5 squared.
Okay, 6 times 32.5 squared.
You get 6,337.5
Oh,
inches.
let's see, 6 times 32.5 squared. 6,337.5. Good. 6,337.5 inches what? Squared. Good. Very good. That would be our surface area.
And then the volume.
Okay, so tell me about the volume.
You take 32.5 to the square, cubic.
Cubed. Good.
You're going to get 34,328.125.
Woo, big number. So remember to do cubed. It's never even a bad idea to write this. So you could write 32.5, your little up arrow, 3, because that's what we're doing. 32.5 up arrow, there it is, 3 for cubed. 34,328.125.
Inches cubed.
inches cubed. 34,000. You could put a comma there if you want. You could do it there too. 328.125 inches cubed. There we go. Kind of cool. So, I've shown you some on paper. We've written down our formulas, and now here's the activity we're going to do. I have printed out some nets for you. I am going to have you guys measure either with your rulers or with your little tape measures at your tables, up to you. We're going to measure the side lengths, make sure they're all the same, and I want you to find the surface area and the volume of what this cube will be. But I also want you to cut this out and try to put this cube together. We're going to make little cubes today. So let me pass these out, and I'll keep this up here for you to see. Let me pause this. So each of you should have one of these, and I'm going to write some directions just right on here. So, because this is a cube, you should be able to just pick one random line, and all of these lines should be the same length. So, measure one side length measure one side length, and that's going to give you the S that you need. Once you find your S, I want you to find surface area and volume and you can write on here. So like I might go ahead and write S equals something. And then right here I might say my surface area equals, my volume equals. Okay. And then once you've done that, your third step is to cut this out. Cut the net out and put your cube together. Okay. So if you are measuring, you can choose if you would rather do it in centimeters or inches. I'm okay with either. Just make sure you're lining it up real nicely and being as precise as you can. And find your S. Now these little shapes on the edge of each square are just tabs to help make it easier to put it together. If you don't want to include the tabs, you don't have to, but sometimes it makes putting your cube together a little bit easier. So I am going to cut one out as well, but I'll leave these directions up here. And if you get yours all cut out and your measurements done and figured out, I have tape up here at my desk. There's, I think, some little glue sticks you could use. I've got tape over by the assignment tray, and we're going to want to put these together.